All right, so this is the second day on the unit circle, and we have to be able to go beyond the easy ones. Like the easy one might have been, where is cosine? See, again, I hope at this point this will be like, come on, it's too easy. Where's the cosine of 3 pi over 2? Figure out the answer. You can find it on your chart that you made a second ago. Cosine of 3 pi over 2. 3 pi over 2 is right there. Boom. Cosine of it is the x of it. It's 0. Raise your hand if you get that. Okay, good. So what happens when the numbers aren't so nice? One of the problems yesterday was like this. I'm going to put you in a place where tangent of the angle I have will come out bigger than 0. And I'm also going to tell you that the sine of the angle in question is equal to negative 4/5. Wait a minute. My brain's starting to hurt. Okay, so where should I draw the triangle? How about this? The fact that I said tangent is positive, do you get that all of them are positive here? Sine is positive here, tangent is positive here, and cosine is positive here. All students take calc. That's a big thing. If you haven't got that memorized yet, memorize it. So then if tangent's positive, you get I have to be either here or here. Can't be there, can't be there. So this is out and this is out. You get what I just did there? Because tangent was positive, it has to either be in here where all the sides of the triangle are positive, or here where all the sides of the triangle, well, the opposite and the hypotenuse, no, not the hypotenuse, the opposite and the adjacent would both be negative. That's why tangent's positive in these two places. So far I could have two triangles, here or here. But then I said sine was negative. Do you get how it can't be here now? All right. So now I've got it narrowed down for you to this one triangle. So would you please label those sides and figure out what the cosine of this unknown angle would be? That is from yesterday. See if you can do it. Since you're done, let's give this one a shot. Would you agree that sine is opposite over hypotenuse, and therefore this was the opposite and this was the hypotenuse? The opposite is negative 4. The hypotenuse side is this one, is 5. And some smart kids will ask me, how come you don't put the negative on the 5 and make this positive? Because a radius is defined as always having to be positive, and the radius will always be the hypotenuse. Hypotenuses are always positive in this scenario. Okay? This number can be negative because it's going down. And going to the left is also a negative number. So when we figure out this number, which I know some of you know is a 3 because it's the 3, 4, 5 triangle, if you hadn't been able to do that really quickly in your head, you could have done this. Square root of, and then 5 squared is 25, 4 squared is 16, 25 minus 16. What is the square root of 25 minus 16? Well, it turns out to be square root of 9, which is 3. But do you get how it'd be super easy to do all that calculation and get the answer of 3 and forget that it's negative? A lot of people forget that. So many of you are going to be guilty of this, that there will be many people on Wednesday of next week when we take this test who are going to forget a negative, and they are going to say, the only reason I didn't get an A is because I forgot a negative. I guarantee you there'll be like 8 people in here who will be able to make that statement. Okay, because yeah, it's a big deal. When I say it's negative, it's the opposite of your answer. Okay, so anyway, be careful with those. I'm going to do another one and we'll see if anybody catches it later. All right, did you then figure out the cosine of it? Mr. R, what did you think? What do you think the cosine of this angle would be? Because this is the angle, right? So yeah, negative 3 over 5. Raise your hand if you're getting that. Okay, good. Then let's try, looking for some feedback here. Let's try another one just like that. Get to a blank one of these. For me, I can go here into my gallery and just drag one out. If I have a pen in my hand, it's not quite as clean. All right. So I'd like you to take this little puzzle that I'm about to give you and try to figure out where to draw the triangle, what to label the sides as, and then actually answer the question. All right, here's my first clue. This is all going to be going down. between pi over 2 and 3 pi over 2. My angle is between pi over 2 and 3 pi over 2. And sine of theta equals 0. Good luck drawing the triangle for that. What's theta got to be? I'll pause for a moment, see if we can figure it out. All right, let's see how many of you got this mastered. Do you get when I said between this and this, I had to be between here and here? And that means in this zone right there. Okay, if I'm in that zone, where is sine equal to 0? What? Well, sine's the y. So where is y equal to 0? Boom, right there. Where is that? The thing I don't know is the angle, right? 180. What if I said the answer had to be in radians? Pi. The answer is pi. Okay, they give you these in lots of different ways. Sometimes they'll say it's in here between this and this. Other times they'll say, they could have said that a different way. Let me show you another one like it. So let's do one more. And if tangent, sorry, gotta remember to put the marker down when I do that. If tangent is positive and cosine of the angle is negative 3/5, what's the angle? Open for 30 seconds or less. Whip out the triangle real quick. Made the numbers nice. I'll pause while you try this. Okay, I'm going to just get started because some people may be drawing it in the wrong spot and might be wasting their time. If tangent is positive, I'm going to refer back to all students take calc. Have you figured out what those mean yet? A is all of the functions. S is sine. Sine's positive. I don't care. I want tangent positive. Oh, yeah, that's here. That must be here then. Is this the only place it could be? No, tangent is also positive here. But this is out and this is out. And then cosine's negative. If cosine's negative, can't be there because everything's positive there. Cosine's negative, I'm back in here again. And if I'm in there, cosine is adjacent over hypotenuse, negative 3, 5. We just did that one. Therefore, this side is 4, except it's negative 4, because it's a 3, 4, 5 triangle. How many of you remembered that it was negative? Okay, awesome. And the final answer is, what's the angle? Trick question. You don't know the angle. Oh, say that again. No. I thought you were going to do it with an inverse, because you know how you can do inverses? All right. I made the question too hard. You can't be expected to find the answer on this kind of a question, because it's a weird decimal like 22.8. It's not 30, 60, 90, or 45. So what I could expect you to find was tangent of the angle. Even if I don't know what the angle is, I could ask you for the tangent of the angle. Well, how could you do it if you don't know? Because you got the sides. All right, figure out tangent of the angle, even if you don't know the angle. Correct. With a calculator, it'd be no problem. I mean, I shouldn't say that. It wouldn't be super easy, but you could do it. You know it's 180 plus that little angle. Figure out the little angle by inverse tangent, for instance, inverse tan of 4/3. Could have got you the decimal and you add 180 to it if you want degrees. But that's the long answer. The short answer is, I wanted you to see that you're not going to get the answer for the angle, but you can still get the tangent of the angle. It's kind of weird. It's like, how are you supposed to know the tangent of it if you don't even know what the angle is? Because you've got the sides. Tangent of this angle is opposite over adjacent, negative 4 over negative 3. Negatives cancel. The answer is 4/3. Raise your hand if you had that one right. Okay, good. Now let's start your homework. Because believe it or not, I think you're ready. I'm going to pause for a second while we pull that up. Okay, so here we are on slide 31 of the 12.2, and technically this puts us in day 2 of this presentation. Notice this little limit has been put into the directions between 0 and 2 pi. Think about it. 0 to 2 pi, isn't that the whole circle? So why do we have to limit it to that? Because technically, when we graph like sine, which is what they're all based on, it goes forever. Do you get how technically if I say what's the angle answer, if I say like where is it a half? Well, this is where 1 is, so here's where a half is. And there, and there, and there, and there, and there, and there, and it goes forever. See what I mean? So you have to limit it to only between 0 and 2 pi. Here's where 2 pi is. We only want those answers. Typically, they'll be like 2. That's in the context of the graph. Okay, so now let's go back to our circle again. I bet you have this one memorized. I told you to memorize it. Sine of what angle is a half? 30. So easy for a kid to get it wrong because they put that. Because what does it say in the directions? In radians. Okay, so pi over, that's like 180, right? 180 divided by what is 30? Pi over 6. Yay. Still wrong. What? What's the directions actually say? All the angles. Remember me saying there's going to be probably 2 that are in the circle where sine of the angle is a half? All right, so I'm going to have to go on to my little thing here. And if you have your chart, which you do on your desk, if sine is a half at pi over 6, do you get how if you transport right over here, sine will also be positive 1/2 over there? Oh, students take calc. Sine's positive over there. That's another spot that works. So the answer is 150 degrees, except in radians. 5 pi over 6. So pi over 6 and 5 pi over 6. If that hadn't worked, you could have dropped down here and saw if it worked down here. And if that hadn't worked, we could have popped over here and saw if it worked down there. But we knew that sine is positive a half. It's so easy to forget that they're telling you it's positive because you just think of a half as not being positive or negative. You just think of it as a half. But it's positive. Sine is positive. So it has to be here and here. That's where your 2 answers are. Same idea on this next one. Cosine is negative. Do you get how they're telling you cosine's negative? They're telling you it's negative that. But if they're telling you cosine's negative, all students take calc. Where's cosine negative? Well, it's not here and it's not here because those are places where cosine's positive. Do you get my 2 answers? Are going to be here and here. It's just exactly where are they? Well, you can look on your chart. Or you could go, okay, I'm going to draw a triangle. And what are the sides? Cosine's adjacent over hypotenuse. Adjacent here is -2. Hypotenuse is √3. Is that a triangle you know? Yeah, that's one. That's the 1, 2 √3 triangle. No, it's not. No such thing. So what do I do? Well, could I figure out this last side at least? Can I figure out the last side? Okay, let's figure out the last side. It's going to be the square root of √3 squared, which is 3. What? What? Yes, but from this angle's perspective, isn't that the adjacent? Oh, do I have an upside down or something? Okay, hold on a second here. Cosine's adjacent over hypotenuse. That's the adjacent side. Oh, duh. I just could not get through my head. Sorry about that. That's the adjacent. See, if I label it, then I can do it. Adjacent, that one's -√3. And the hypotenuse is 2. And it is a 1, 2, √3. Okay, cool. At least I noticed something was wrong. I didn't just forge ahead and you figured out what was wrong for me. I appreciate that. So this is it is a 1, 2, √3 triangle. Good, so then it is just 30 degrees. So yes, just 30 degrees, right? No, because it's this angle here, which isn't 30, it's 150. So if you want to make that in radians, this would have been pi over 6, and that'd be 5 pi over 6. Otherwise, you could have taken your 150 and converted it into radians. But okay, is there only one answer? A lot of times there's two. There's another spot where it's going to work down here, and it's pretty much the same thing. It's another pi over 6 kind of deal. So I go, that's 6 pi over 6, and there's one more pi over 6, 7 pi over 6. All right, your assignment is to do this first page up through, through 36, this whole page. Then we're going to go to the next page, and we're going to do these. And I think, make sure we can do these. Yep, we can do those up through 42. Yep, we're going to stop at 42. Just let me show you how many we're missing here. We're skipping. We're skipping 1, 2, 3, 4 pages, 4 pages plus some challengers. Okay, so I am cutting your assignment down here. So I expect this to be done up through 42. Okay, if you know what you're doing, these go pretty quick. By the way, these are not the answers. They're saying you can only give answers between 0 and 2 pi, which usually means there's 2 answers. By the way, usually implies not always. Sometimes there's only one answer, but a lot of times there's 2 answers. How could there only be one answer? Like that one where he had sine of the angle was equal to 0. That would only have one answer if you're limiting it to this quadrant over here. Okay, say that again. Good question. If it doesn't say, default to radians, because the test is going to be radians. I know you can use degrees. There's nothing wrong with degrees, but you got to be able to convert them. So if you say, okay, I figured out the answer comes up to 120 degrees, you better be able to change that to radians because the answer will be radians on the test. I'd like to think of that as 2 60s to make a 120. And a 60 is pi over 3. So 2 pi over 3 would be the same as 120. You can do it with the complicated 120 times pi over 180. That works. But I really love it if you start thinking like 120 is 2 60s. And 60s are really pi over 3s. So to do that, you really got to be fluent with the simple ones like pi over 3, that's 60 degrees. Pi over 6, that's like 30 degrees. Pi over 4, that's like 45 degrees. Those are the big ones. All right, so these are going to bother some people. Let's look at number 10. Let me just ask you, if they give me this clue that it's between 0 and 2 pi, or sorry, pi over 2, do you get to give you a big clue about where it is on the circle? If it's between 0 and pi over 2. Here's 0, here's pi over 2. It's got to be in here. This is out, this is out, this is out. That was huge, right? And the sine of the angle is 2/3. That means, okay, if I draw my little triangle here, sine is opposite over hypotenuse. You should be able to set up the sides. Okay, I don't want to do the whole problem for you, but the weirdness comes in when they do this. Pi plus theta? If I had figured out the angle, and I'm going to pull up on my other screen over there, wake this thing back up again, the unit circle, because you guys have a unit circle on your desk, right? Okay, everybody put your finger on your unit circle on pi over 6. Let's say we figured out it was pi over 6. Put your finger on it. Now add a pi to that, also known as 180 degrees. You get how you just have to swing around your circle? How far around your circle do you swing if you go 180? If I was at pi over 6 here, I'm going to swing around 180 degrees. It's like that. So if I was going to give you the answer for, what is it, sine? If I was going to give you the sine, which is 1/2 there, but I was forced to swing another 180, do you get that's going to change it to the sine here, which is -1/2? All right, so when you add pi, you're going to swing 180 degrees. What if you do like this next one, or this bottom one, and you add pi over 2? It's kind of like adding how many degrees? So it's like you swing around the circle 90 degrees from where you were. All right, and then last but not least, if I had said 2 pi plus the angle, that would mean you would just go 360 around and be the same exact spot, right? But what does it mean to be 2 pi minus the angle? I'll let you think that through. Maybe it has to do with a full circle somehow. All right, so I'll stretch you a little bit, but that's probably as far as we need to go for today. Okay. Then when you come back on Monday, we will have Monday is going to be our last intense day of learning stuff. And then Tuesday is a review, and then Wednesday is a test. Do you know all of circle trig? Of course not, but we've covered almost everything that would be on the test already. All right. That's all I got for you for today.